Hello again after the lunch break. Ladies and gentlemen, welcome to the technical forum of Hydrogen and Fuel Cells Europe at the Hannover Fair 2022. My name is Bernhard Jekel. I'm the moderator of the stage today. This moderation and the next speech. And we like to present you lots of information about the newest technology. The next presentation will be about hydrogen storage, required improvement for the technology. And we get here the Business Unit Director Energy Solution of Hensoldt NEXEYA. Please welcome with me Dr. Ludovic Madier.
Thank you for this introduction. Hello, everybody. So, Hensoldt Group is 5,000 people working in Germany, in France, and all over the world, approximately 30 different countries. The company is traditionally have some activities in defense and also in civilian application, in civilian industry. And we developed energy solution for traditional energy power sources. And since approximately 10 years, we are involved in hydrogen application. And in our hydrogen application, we have met the difficulties of hydrogen storage. And that's why we decide to develop our own solution. We develop our own pressure vessel with our company named Madier. This company is based in France. We use Type 4 pressure vessel, and we integrate this pressure vessel, 500 bars, within 20-foot containers, which are commercialized under the name of HDS, stand for High Density Storage Container. It is a key issue, the hydrogen transportation. Everybody knows that the specific energy stored in gaseous hydrogen is quite limited, especially compared to traditional energy power sources. So instead of with the competition with traditional energy, with the increase of the environmental concern, the increasing of business of hydrogen, we have to face, and we are committed to propose alternative and try to decarbonate altogether our industrial activity. And in this case, we are very proud to participate of the developing. We are proud to participate of increasing the opportunity of hydrogen distribution. And this solution of containers can be used in different applications. Logistics of hydrogen is the key because the needs are quite spread all over countries, and the need cannot speak anymore. Thank you. The need of hydrogen energy can be everywhere can be spread over the country. It can be used for gas to power application, which is also something we are developing for off-grid or microgrid application, especially for isolated island, like we have some tropical island for France country, which are needed microgrid support. And hydrogen can be the key, because hydrogen can be stored for long term and can be delivered in some remote places and then power for long term also some specific application. The specific application could be some, I will show it later, can be some antenna, can be some small village, for example. But in any case, the need could be several megawatt hours So it means roughly half a ton of hydrogen that can be stored within the containers. And these containers have to move rather easily, so it have to support the certification for transportable container of gas exactly as it is proposed here within this product, which is an MEGC, which stands for assembly of gas containers. The different application of these key tools, which can increase the usage of hydrogen application, is the modularity that can be brought by a containerized solution. It can be used also for ships power supply, as it is easily swapping exactly as traditional commercial containers. So this use can be modified and studied to be used as a tank of the ship itself. It needs to increase the level of the certification and the level of the studies, safety studies with the ships. So you have to comply to a standard code, which is IGF, which is a traditional code for dangerous fuel for ships. In some of our applications, I will detail rather quickly some off-grid renewable energy solution also use hydrogen storage and need to increase the capacity of storage capacity, but also the long-term storage, which is not possible with traditional battery electrochemical storage. With hydrogen storage, you can store energy for all season, especially for winter season. In this case, during winter season, you have no electricity produced by photovoltaic panels, and then the electricity is produced during summer, converted in hydrogen, and stored for a long term. So it has been a challenge to increase what we call the permeation, the capability to store hydrogen for a long term within the tank, within the pressure vessel, to keep it for a full season, and then during winter time use hydrogen to produce electricity, and instead with a fuel cell, instead of using electricity from solar panels, which are not available in winter. Another challenge also to face with the storage is when you associate hydrogen with microgrid, you have to face some regular usage, and especially in one case, I will switch directly on this use case, which is in Germany, in one of our premises in the north of Germany, in Kiel. We have to combine both local production hydrogen during seasonal summer, for example, when we produce green electricity from solar panel, then produce hydrogen, but it's not enough, especially in Germany when the sun is not, even if today it's quite sunny, but the capability of production is not fully enough to supply the building. So we use this modularity of our containers to use waste hydrogen from an industry close to our premises to complete the quantity of hydrogen we need to supply the building, and then reduce the global gas emission to zero, to reduce to 100% of green electricity production on site. Only 2 minutes left. Just a small movie during a short movie to put in a nutshell what we are doing in the Hensoldt Group. The idea of our development is to be able to be usable in different places, as we are a defense company but also a civilian company. And we have the ambition to be able to support power plant, which is the traditional activity where you have hydrogen produced in the power plant. We can both store hydrogen during the production and then restore under electricity form, especially for grid support. For airport, a lot of airports are now moving and try to green the at the maximal level, exactly the same for maritime. They try to introduce hydrogen technology to reduce their carbon footprint. So two types of application for the ship, but also for what we call cold ironing. Military bases is also a very interesting application. We can see some hydrogen ecosystem developing in military camp. And finally, the last one, the off-grid application I explained before in remote places. So thank you, and I will stand to the booth just over there if you have some question. Thank you.
Oh, thanks a lot for this presentation, Dr. Ludovic Madier. Nice to have you here. Bye.